Hey, this is Doug from Vanstrom Performance. I wanted to make a video about setting up air dump shocks and controlling them through Holley or any other ECU. This particular car has Holley EFI, has a Holley Dominator in it. The car is equipped with Penske air dump shocks that were done by Adam Lambert at Precision Racing suspension. And it has an air dump solenoid from Modern Racing. The reason we're using the Modern solenoid is because we need to have about 180 psi of CO2 to these shocks to start out with. A lot of the solenoids that people use, whether they be Mac valves or anything else, can't handle that type of pressure. So we're going to use the Modern solenoid. It's part number MR-0113-002. You can get it right from Modern Racing. They also have a air shock plumbing kit, which is part number MR-9902-001. Also comes with a template, so you can mount it. And there's an optional electrical relay and wiring kit that you can purchase with it if you want. I didn't need any of that. I'm using my own relays and wiring and Deutsch connectors and everything else here. So it's just an option to use. Obviously, you can get a hold of Precision or your favorite shock manufacturer if you're going to use air dumps or not. It depends on the situation in the car. This is a no prep car. The customer decided that he wanted to go with an air dump style setup. So that's what I put in. I originally thought I wanted to use a normally open solenoid, which would provide CO2 to the shocks whenever the bottle was on, and then you just dump the pressure off down track. After talking with Modern, they convinced me that the normally closed relay was the way to go, and I agree with that. Basically, so that way the customer, whether he's on the street, cruising around, what have you, he can keep his bottle open and it won't provide CO2 to the shocks and mess up his ride and everything else. So we have it set up now with a normally closed solenoid where it only applies CO2 to the shock once parameters are met. The way this car is wired is I have a virtual switch on the Holley 7-inch screen, which turns the solenoid on via relays and provides air to the shocks. The shocks are dumped during bump-in, so it won't upset the chassis. That was another recommendation by Modern that they use. So basically it has CO2 to the shocks until you hit the bump button. It dumps the air while you're bumping and then reapplies. It's very fast. And then once you release the trans brake, you can push the trans brake, and once you release it, it has a timer, which is also programmed into the Holley, that will hold the CO2 onto the shocks for a period of time. Right now, it's just 1 second, and then it'll dump the CO2 off. It just vents it to atmosphere. But it vents it without venting out your bottle, which is what was one of the concerns that people, when I started researching this, because I hadn't hooked this stylus system up yet, people were worried that, well, when it vents the shocks, is it going to vent my bottle out too? The way this is set up and with the solenoid, it does not. So your CO2 stays. The only amount that gets vented is what your shocks have in it. It releases out. And then about 12 seconds after, that's the current program, after it's released, it's going to go ahead and reapply the CO2 to the shocks. So hopefully the customer's in the shutdown area, slowed down or turning off or what have you, being an 1/8 mile car. If it's a 1/4 mile car, I'd extend that out a longer period of time. Also, when you either cycle the ignition off or turn the virtual switch off, it automatically dumps the CO2, and it's done. So you don't have to worry about having CO2 on the shocks all the time. You don't have to worry about opening and closing the bottle all the time. If it's plumbed right and it's wired right and it's programmed right, and there's no leaks in the air lines, you can just leave the CO2 bottle on during the day, maybe shut it off at night or when you're done racing, and then you don't ever have to worry about it. It's not going to put CO2 to the shocks until you actively arm the switch, and then obviously it's controlled from there. So I'm going to give a quick rundown of how I've got this wired, and then I'll pull out the laptop and show you how I programmed it, and then I'll give you a rundown on how this works. All right, so I don't have any fancy diagrams or computer programs or anything else, so I just draw this stuff out. This is what I'm using to control the 12-volt side of the relay. All right, I'm sorry, of the solenoid. I'm controlling both sides of the solenoid via relays. And the only reason I'm controlling the ground side with a relay is because this solenoid, I believe, takes more amperage than what the ECU output can provide. So in this way, I'm kind of protecting the ECU output, only letting it switch on a relay to provide a ground for the solenoid itself. All right, so let's start here. This is your standard 5-pin relay. You have your power supply here. Usually goes to pin 30, which is how we're going to use it on this one. Now, in a normally open situation, this pin 87A, which is on every 5-volt or 5-pin relay that's not just a dual normally closed, okay, it's going to provide, if this is a 30-40 amp relay, it's going to provide 40 amps right here. So basically, these two are connected all the time as long as this relay is not engaged. All right. So this is how I'm controlling the 12-volt side of this. The power of this to this solenoid is hooked right here. When we turn the battery on, it provides 12 volts. But don't worry about it. It doesn't have a ground yet. Okay. The relay is going to get grounded to the chassis, and the ECU is going to provide switching. And what this does, the only thing that this provides, the ECU provides for this, is a timer to release a trans brake. That's how the output is set up. So when you release a trans brake, and this is going to enable a 1-second delay, and then it's going to switch this relay on, which takes the power away from here and switches it to here, which essentially takes away the power to my solenoid, and it goes to its normally closed setup, and I'll explain that in just a second. The ground side, instead of having a 12-volt supply here, I have a ground here. This ground is now switched from the ECU. When I turn the switch on, and this is grounded through just as a fused 12-volt constant to this pin here, when I activate that button on the dash, it gives me a ground switch. It connects these two, and it gives me a ground signal right here. Now this ground is now connected right to that solenoid. So that way the solenoid cannot be active. Even though it has 12 volts here, it cannot be activated until that switch is turned on. Now when I hit the bump button, this goes away. All right, the way I have it programmed, 2 parameters have to be met. This switch has to be on, and the bump has to be below 4 volts. If I hit the bump button and it provides 12 volts to the ECU, this goes away, shuts my solenoid off. That's how we're working now. Now, a normally closed solenoid is exactly that. It's normally closed. It doesn't free flow through. You feed the CO2 right through here into port 1. With this plunger down at the bottom, it blocks off any CO2 going anywhere else. When you activate this solenoid, it lifts up and it blocks off this vent. Now, when this is a normally closed state, 2 and 3 are hooked together. All right. So anything that comes back from the shock, when you release this pressure, goes right out the vent. When you activate the solenoid, this raises up, it blocks off port 3 and allows the CO2 feed out of port 2. All right, so basically these two are now connected. I've got a pressure on my shock. When I shut the system off, this closes back off. The air pressure from the shock comes back out through the vent. Okay, so now obviously this here is going to be connected here. I'm trying to film this and write at the same time, and obviously I'm not very good at it. This one here, it's going to be all the way over to here. It looks complicated, but it's really not. And of course now it's starting to rain and my shop is loud when it's raining. So I'm going to do a quick show of how this setup works in the car, and then I'll go over the programming really quick. Okay, so here we are in the back of the car. This is where I have the solenoid mounted right here. This is my feed right here. This is the feed to the shocks. It comes up and splits and goes to the shocks. This here's the vent. All right, and just for now, I don't have the upper bar in this thing yet, so I haven't mounted the CO2 bottle, but it's just there for now. Now we have our virtual switch programmed onto the dash. Okay, now once again, this provides the ground output from the ECU to the relay, which is going to turn on the solenoid. It already has 12 volts. Okay, there we go. Let me open the CO2 bottle so you can actually hear it. So say we're bumping in, we don't want CO2 pressure on there. You hear it popping off. If we shut the switch back off, it vents it. Turn it back on, it reapplies the pressure. So we're staging, we've bumped in, we're holding the trans brake, let go of the trans brake, and it vents. Once again, 1 second timer. Now after 12 seconds, this is going to come back on, reapply CO2 to the shocks. Just like that. Okay, it's a very simple setup. You're driving around, keep the CO2 bottle on, keep that off. Keeps the CO2 off. That's how this all works. Now I'm going to go to the computer and show you how I set it all up. Okay, so here we are with our Holley EFI version 6. Let me go to my inputs and outputs and show you how we set this up. So right here, we have a shock dump switch. It's just a ground through the LCD. So that way it's, you can hook it up through a regular switch, through a pin in the ECU, that's fine. We wanted a virtual switch on the dash, okay? Outputs, pretty simple. We got a shock dump positive and a shock dump negative. Let's start with a negative. Pretty easy to configure. Our switched input trigger is the shock dump switch on the dash. That's going to enable it. But also, this is and, not or, it is only active when the bump button is below 4 volts. All right, now if we hit the bump button, and it's going to give it 12 volts, which is going to deactivate this. Now this is your ground output. It shuts off that relay. No relay, the solenoid can't do anything. No linked outputs and no timers. Okay, this is just controlling the ground on and off. We'll go back to our positive. It's configured a little different. Very simple. Trans brake launch at input release. So when you launch off the trans brake, it activates this output trigger with a timer set up. 1 second activation delay for 12 seconds hold. So this will delay the amount of time that it tells the solenoid to turn on. I'm sorry, to turn off. So it's going to turn on the solenoid. It's going to turn on the relay, I'm sorry, which takes away the power from the solenoid. All right, remember we're in normally open versus normally closed. We have constant 12 volts on the solenoid all the time until this activates and takes it away. All right, I know I've said it back and forth a few times. Maybe I'm just trying to convince myself that I did it right. No, we definitely did it right. It works great. This is a good way to do it. If you're using a different program, you can set up things in a completely different way. But given the options of what we have for enabling things, I felt that the 2 relays and controlling both sides of those relays, or controlling both sides of that solenoid, was the way to get the best out of this. Now, the first thing I did try, I used an input trigger here, where I thought that maybe if I hit the bump button, it would just deactivate the stage. It doesn't. It goes right to the timer. So when you hit the bump button, you have to hold the bump button for a full second before it activates the stage. So I realized very quickly I couldn't do that. And that's why I went to the negative side, where I could just deactivate it by going over 4 volts. And the reason I have 4 volts on there is just in case there's any voltage spikes of, just some weird something seeping through the button, because it is 12 volt. It needs a full more than 4 volts in order to activate this, so that way it can't just come on and off and on and off and on and off with minimal voltage spikes. If you put it at 0 and there was some voltage leakage through the button, it could just do stupid stuff. So that's how it's all set up. If you have any questions, just go ahead and PM me. Thanks a lot.